Welcome back. In this lecture, we're going to begin our discussion of theory and tuition with some very basic terminology behind decision trees. So in order to really understand the various topics we're going to be discussing, I want to first make sure we understand the terminology and vocabulary about the various components of a decision tree. And let's recall this really simple regression tree that we have here that is essentially just modeling out a continuous prediction based off some feature X. I want to really talk about what each of these components, vocab or term, is. So let's start off with discussing splitting. As you may have guessed, splitting is really just referring to the act of taking in data at a node and then splitting it whether or not that condition is true or false. And you just heard me use the term node. So let's talk about the nodes and the various types of nodes. Theoretically, everything you see here as far as where the condition is actually being tested is a node. So data is entering a node, it's being checked against a condition, and then split into another node. Now, there are specific types of nodes. The root node is at the very top of the tree, and that's going to be the very first condition or feature that you check or split on. Then there are leaf nodes, otherwise known as terminal nodes. Terminal nodes or leaf nodes have no data going out of them. That is, the data is no longer split once you reach a terminal node, which essentially means that your decision of what the output should be occurs at a terminal node. Now there are also relationships between the nodes, and these are sometimes known as parent-children nodes. You won't really hear us refer to this too often, but I do want to actually explain what this really means. Here we have a green parent node on top, and then the resulting nodes after a split are the children nodes. And we have another relationship here. So again, the green node at the top is a parent node, and then after the split, you have the children nodes. I should also mention that sometimes people refer to as subtrees or tree branches as part of an overall decision tree. So this is a relatively small decision tree, but it actually does have a subtree within it. Essentially just saying that it has an off branch or off split that leads to a node that leads to more splits that leads to more nodes. Now the last thing I want to mention is pruning. Now the idea behind pruning is the fact that in theory you could actually make this decision tree shorter. You'll notice that we have a node checking if x is less than or equal to 2, and that leads to two results. If it's true, we output y is equal to 2.2. If it's false, we output to y is equal to 1.5. The main idea behind pruning, and we'll discuss how this is actually mathematically done later on, is that instead of actually having the leaf nodes continue after the split, is to essentially decide not to split at this node and have the node above it be shortened to become some sort of terminal node or leaf node. So I could, in theory, prune these two leaf nodes off, which would then make this node some sort of leaf or terminal node. Now, the idea behind pruning is to help avoid overfitting. As you can imagine, you could check for a variety of conditions on that x feature. Instead of just checking for something like x is less than or equal to 2, you could have checked for x is less than or equal to 1.9, and then have another node checking for x or less than or equal to 1.95, etc. So you can see that in theory, you could have really granular nodes which could cause overfitting, in which case you would prune this back up to have a more biased machine learning algorithm with the decision tree. And we'll see that with scikit-learn and Python, we can actually clarify how deep we want the tree to be built out. Now let's move on to discussing all the mathematics behind how we actually construct a tree, since we now understand the vocabulary and terminology behind a tree. If you understand the terms nodes, splitting, and pruning, then you're pretty much good to go. I'll see you at the next lecture.